Oh, good. It's hard to remember. I know.
I just need to start it up, right then. Jeez. I'm gonna have to have somebody else start the meetings. Sorry, guys.
That's all good.
Well, oh yeah, I got we're 4 for 4 so far.
All right, so let's see. Where are we at? In no less than 3 sentences, please define the 68 to 95 and 99.7 rule. So that's describing a bell-shaped distribution. So what that means is that 68% of the data will be within that 1 standard deviation of the mean. And then 95% of it will be in 2 standard deviations. And 99.7% of the data will be within 3 standard deviations. So
more than 2.
I'm sorry?
Just more than 2. So
yeah, right. Okay, yeah, exactly. More than 2. So that's why they call it the 68, 95, 99.7 rule.
Right.
Because those are the values.
Kind of an interesting name to a rule.
Yeah, exactly.
Numbers.
Yeah.
This rule's called the 619.872 rule.
Right. Yeah, I imagine it gets confused with a lot of other rules since it's so similar to.
Mm-hmm.
Yeah.
Okay, I'll go for number 6. The mean score of all GRE scores is 150.8 with a standard deviation of 8.8. The scores on the quantitative portion of the GRE are approximately normally distributed with a mean of, it gives us that. So 150.8, standard deviation of 8.8. Is it something that? Yeah, I'm back in there. Oh, okay. What proportion of the people who take the quantitative portion of the GRE will be score above 165? So what we do is we take 165 minus minus 150.8, and then you divide that by 8.8. Let's see. That should give us the z-score. I'm going to do it on my phone. Just correct me if I'm wrong if you're doing it. Actually, oh, yeah, you did that? Nice. You got, oh, yeah. What did you get? Yeah, so the x, that's going to be, what's the mean? The mean is 150.8.
Yep.
Your deviation is 8.6. And then the number we're going with is 165. 165. So it should be 1.61. Yeah. Cool. The other way. And then we'll go to our tool. And we type in 1.61. What was the question? I wanted to know.
The proportion.
Who will score above? So, you know what? I'm being kind of dumb. I should just share my screen so you know what that. There we go. Okay, so back to here. I just typed in 1.61, and we want to know if above will be 5.4%.
So the answer was they had 0.0533.
Yeah.
That's probably is that a rounding?
Yeah, 0.0527, but just for rounding purposes, I just made it
Yeah. So we're in the.
Okay, we're good so far?
Yep.
Okay, if the student's score is the 10th percentile, what would their corresponding z-score be? So we just go back to this thing and say 0.1. Their z-score would be 1.282.
Yep.
Say that again. 1.282. You go into the normal probability output and type in 10% here and then pops everything. Okay. And the last part, what is the quantitative GRE score for a student who scores in the 10th percentile? Oh, so we have to solve for X now. Okay.
Is the 10th percentile the lower portion of the curve? 90 has to be the higher portion of it.
Yeah.
So it'd be the median.
Yeah. So it'd be negative 1.282 for the z-score.
Right.
Do you have a calculator for that?
Yes, I do.
Sweet.
For figuring out the other way.
Yeah.
Okay, what's the z-score?
Negative 1.282. And
It
then
comes out to be 139.52.
139.52.
Okay.
I believe that's. Is that what you guys got?
Yeah.
All right. Let's check it up with the answers. I mean, does it match up? Anyone
Looks
goes
good. Yeah.
back?
They rounded it to 140, but that looks good.
Oh, okay.
Oh yeah, because you can't get it from there.
Okay.
And-
Okay.
But then you get any credit.
Okay.
You want to keep going on that, and we'll just since
Sure.
you have that up. Is that all right with you?
Yeah, I'll just read them off and you can type in the numbers and they'll check our answers.
Yeah, I can even present on my.
Okay. The mean speed of hydrogen at room temperature is 1,800 meters per second with a standard deviation of 600 meters per second. Say that again. So the mean speed of hydrogen at room temperature is 1,800 meters per second, and then with a standard deviation of 600 meters per second.
Yeah.
At room temperature, means okay, we just pull that out. 1,800 and 600. What is the probability that a randomly selected particle has a speed over 2,500 meters per second? So we just find a z-score. So the x would be 2,500. We're trying to calculate the z-score.
Oh, z-score, so 2,500?
Yep.
Okay, z-score comes out to be 1.17. And because you take the value minus the mean,
That'd be the minus the 1,800. Yep.
that has 600, which comes up to 1.7.
Yep.
I lost my lab. Okay, it's coming back. 1.17. Okay, and they want to know.
They want to know the probability.
Oh, that it'll be over. Okay.
Yep.
So that is 12.1% or 0.121.
Okay.
Yeah, top number.
So, sorry, just 1 second. How did we get for the z to the probability? I can't remember what we're doing there.
So you type in the z-score at the bottom of the
Oh, that's right. It automatically.
Yeah, and you have to make sure you're highlighted the proportions that you want. So if it's under 50%, it's just the one tail end. If it's over 50%, you do the middle and the side or the left little portion.
Okay.
Yeah, I'm sharing my screen now so you can see what I'm doing this time.
Yep. Okay.
what is the probability that a randomly selected particle has a speed that is less than 1500? So same thing, trying to find out the z-score.
1500 for the value.
Yes.
Z-score is going to come out to be, so you're going to take 1500 minus 1800 divided by 600,
Yep.
which is the value minus the deviation divided by, or minus the mean divided by the deviation, comes out to negative 0.5.
And then we'll go ahead and put that in a little half on the left side, negative 0.5. And then we want to know what is the probability that's going to be less than. So we highlight the blue area beneath it, and it comes out to 0.3085. So 0.3. What was it?
0.85.
Yeah, 0.85. Okay. 0.85, which is 3.9%.
Yep.
Yeah, sure. We good?
Yep, looks good.
Okay. What is the third quartile of the speeds of hydrogen at room temperature? During, oops,
Wait, we missed the E.
missed E.
What's
Yeah,
the problem?
The probability that a randomly selected particle.
Oh, I accidentally typed that in the wrong thing. I thought we just did it.
So we already have the two values.
Okay, so what is the probability that a randomly selected particle has a speed that is between 100 and 2500?
We already found the greater
Yeah.
than and the less than.
Right. Well, actually,
minus the two.
we already have both probabilities too.
Yeah.
So yeah, we just minus them from 1,
Mhm.
100%. So that would be, let's see, 100%.
Not from 100%.
Minus,
From-
you sure?
From each other.
Uh,
No, I think you just minus the
So
E7
it wants to know the speed between the two, and we have this speed.
So,
So we've got both of these numbers.
yeah, so we have what's less than 2,500 meters per second and less than 15. So we just need to find the difference.
Oh, okay. Yeah, that's right.
So that would be 57%. Right?
Yeah, yeah.
And then what is the third quartile of the speeds of hydrogen at room temperature? So we just go back to our little app. Third quartile is 0.75. And then, what is it? Oh, what is third quartile? Oh, so we're solving for x again. Okay, so, are you ready?
Yeah.
Okay, so obviously it's, we don't need the, okay, we need the z-score, which is 0.319.
So we're putting in a Z-score.
Yeah, so we need to find x, the value.
Z-score is
0.319.
319.
Okay, and then you should have everything else figured out, right?
Yeah, you can.
Okay.
Okay, the value comes out to 1991.4
Meters per second.
That's nice.
That good?
And you're checking that value, right? Are we looking for a percentile?
Yeah, we're looking for the percentile.
What is the third quartile of the speeds? Yeah, this is the third quartile. We just got it. 1.9914.4 meters per, or 1.991.4 meters per second. Right?
Third should be 75. So you went to your chart, right?
Where is?
Yeah, we have something not quite right on that one. That's different from what the answer says.
Okay, so what you do is you type in 0.75 to the top value of the applet.
Yeah, we did that.
And it
And
gives
we-
you the upper value,
Well,
which should be,
0.319.
it says is 0.67.
Yeah, they have 0.674 or 675.
That doesn't make any sense.
No
For,
problem.
for their z-score?
Yeah.
That's wrong. Can't be right. Because you can see that I put 0.75 up here, right? Yeah, theirs is
Yeah, but
different.
they,
It's weird.
yeah, theirs looks different. So on yours you have, it's calculating the area on both sides. This one is, in the answer they're calculating the,
Yeah, 0.25?
so we want to calculate everything that's up to 75
You can either click the middle and
and the left.
click that one and click the middle. Because it's above 50. No, the middle and that one.
And the, yeah, there you go. So then you're getting, there you go.
Oh,
Okay.
oh, I see.
Oh, there we go. Yeah, because we're calculating the area of everything underneath 75.
Right.
Now to 674.
Yep, 0.674.
Okay. So then
So then I need to
substituting
type
that in
that
there.
into my thing. So 0.674. 4. It came out to 2,204.4.
Yeah.
Does everyone understand how that works too? Sorry, I built all this stuff earlier and figured it out. The equation that you're going to be using is the value equals, if you look at my screen, value equals, it's like, value equals the mean plus the z-score times the standard deviation.
Yeah.
Or plus, sorry, plus, or yeah, times. Okay.
So yeah, it's the value plus the z-score times the standard deviation, right?
Is it the value minus the mean first?
Oh yeah.
So it's just like a little rearranging algebra. So
Yeah.
since x is in the middle, we have to get it out. So we put it on the other side of the equation over here, which rearranges some things, but we ended up coming out with the mean plus the z-score times the standard deviation.
Right. Okay, that makes sense.
When it comes out to what x is. All right, we good?
Okay. Yeah.
Mhm.
Thanks, guys.
Yeah, during your group preparation meeting, you will determine whether the data represented in those Q to Q plots are normally distributed or not. Record your answers for each graph. Justify your answer. So A would be no, right?
No.
B is no. C is yeah. They said kind of like ignore the first and the last ones. And it's generally in a straight line.
Yeah.
And D as well.
Yeah, D is.
One minor exception over here, but
No.
E, I don't think so.
No.
Yeah,
No?
Too big of a
Yeah.
little.
They said it was not
Sure.
normal because it's skewed right.
Yeah, well, it just looks weird too.
Yeah, right. Exactly.
And then plot F would be, that's a normal.
Yeah, that's about as normal as it gets.
Oh, they have the answers related. That's it.
Okay.
We're done.
This time.
Groovy. Should we jump into the quiz?
Yeah.
Sure.
All right. Move over there. Do you guys? Does somebody have the normal probability applet already open?
Yeah, that's right here.
Okay, that's what I thought. Do you mind using that for the quiz?
Of course.
All right, that way then we can just
And
do it together.
I'm still sharing my screen just so you guys can see that I'm putting down the answers in case we don't hear them and like, oh, that's right here.
Okay.
So, does anyone have questions on 1 and 2? Number 3, the total area under a density curve must equal 1, right?
That's what I thought. I thought it was one.
Yeah.
1, not
Yeah.
100.
No.
Oh yeah, because
It's
1 is
Because
100.
yeah, 1 is 100. Right. Did you guys
under-
type out 1 or just put the number 1?
Oh,
Things
I
just
just put the number 1.
Yeah. Okay.
And spell it out.
under certain circumstances, a density curve can drop below the x-axis. That's false, right?
Correct.
Normal density curves symmetric. True.
True. All right, use the following image to answer 6 and 7. Which of the following elements of the figure represents the z-score in this image? Is that C?
Yes.
Oh,
C for Charlie. Which of the following elements of the figure represents the probability that the random variable z will be greater than 1.00?
I don't think it's any of those, is it?
Bravo. Right? The probability will be of the variable z will be greater than 1. So this area over
One right
here is the greater than 1 area.
wait, so, sorry, say that one more time.
All right, so
So
it's
B.
asking, yeah, B, because B is referring to the z-score percentile that's greater than 1.
Right.
Okay.
Okay, because we see the z-score there. Right.
And A is referring to what's less than 1.
So answer to 6 is C, and answer to 7 is B, correct?
Yep.
All right.
According to the 68 big number rule, what proportion of the data from the bell-shaped curve distribution will be within 1 standard deviation of the mean? So that would be 68.
Yeah.
97. Close. Yeah.
Okay, suppose random variable z has a standard normal distribution. Use the normal applet to answer the question. The portion of the value from this random variable is between -1 and 1. Give your answer as a decimal after the third decimal place. The answer was okay.
So we just want to highlight the middle area and z-score 1. All right. Suppose a random variable.
This is normal.
Yeah.
So there's no value.
Well, here, look at the normal.
Between that 1 and 1.
It's between the 1 and 1, and then the middle is highlighted.
The values.
So it should be 0.6827. 0.6837.
6837?
Oh, so yeah, 0.683.
0.683 is what it's mapping. Suppose random variable z has a standard normal distribution. Use the normal applet to answer the question. What proportion of the value from this random variable is between -2 and 2? That's about to be 95 or 0.95.
0.955.
Point.
0.955.
Yeah, 0.99 or 0.955.
0.955?
Yes. And then the next one is just the same thing, so it's -3. And that's 0.997.
So 11 is 0.997.
Yes.
Oh, okay. So it's kind of like the 68, 95.
Yeah. We're just trying to like prove it to us.
It's just the other way of thinking about it.
Yeah.
The amount of data that's in the model.
So does that mean, sorry, back to number 10, does that mean it's not 0.95 or 955? Sorry, I'm having a little hard time hearing.
Well, it said to use the normal applet to answer the question.
Right.
So because the applet said
Goes to
0.99 or 9545, it's going to be 0.955.
Okay, thanks.
Yep.
Values match the. All right, so look carefully at your answers. The last three questions: what do you observe? The values match the 68, 95,
Yeah.
99.7 rule.
Yep. Okay, the amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of good quality protein that must be consumed each day per kilogram body of weight. The population mean protein requirement for adults is, let's put this in the population. So the mean is 0.66. And the population standard deviation
Okay, so then what?
standard deviation is 0.07. Okay. What is the proportion of the population or what portion of the population have a protein requirement that is less than 0.6? So less than 0.6. So, we're typing in the x value to get the z-score.
0.6 is that fine?
Yep.
The score is negative. It's not on a negative end.
I can type it on the
Negative 0.56.
0.6,
Less than.
and it's going to be less than? Yeah. Okay, that is 0.193 if there's three decimals. Yeah, okay. That would be 0.193.
Okay. Oops, hold on a second.
Okay.
My computer's dead.
Uh-oh.
0.193.
Yes.
Okay.
It should say then what.
Are you out of battery?
No, I just put you on.
I'm working out too hard. I need to take a rest. You want to wait for you?
No, I'll just refer to this one first.
Okay.
We'll have a
Austin's,
YouTube video too.
yeah,
We'll have a YouTube video, but
yeah.
keep going.
Austin's computer shut down on him, so
Oh
Yeah.
no.
you can't do anything now. What proportion of the population have a protein content more than 0.6? Oh, well, that's easy. You just look it up then. Okay. 0.805.
What was the question before
Question
Wait.
right before that was what is
Wait.
less than 0.6?
that?
Oh.
Have to be what?
0.193.
So it's 1 minus 0.193, right?
Yeah, or you can just look at it from the normal distribution thing, because we just looked at the less than, and now we're looking at the greater than.
Yeah.
Okay.
194.
So 13 is 0.193, and 14 is 0.805. 805.
805.
Yes.
Those don't add up to 1. Is that okay?
That's 193. Oh wait, you're right. It was 195. I didn't read that. Yeah, 805.
Well, because we cut off some numbers, it would probably round up to 1, wouldn't it, if we added in all the extra numbers from the back?
It rounds up to 195.
Yep. Yeah. Portion of the population concentration that is less than 0.7. Alright, so now we do need a z-score again. So x is our value. We got, and I can do this on my phone. So we got 0.7, which is the value, and minus it from the mean, which is 0.66, divided by the standard deviation of 0.07, and you get 0.571. That is the z-score is 0.571, and we want to know less than. Okay. So yeah, we're good. It's 0.716.
0.716. All right.
Does anyone want to double check my work, or? I mean, I just did this on my phone without looking at anything, so. So z-squared, the x value minus the mean of 0.66 divided by 0.07 gives us a z-score of 0.571. That's right.
Right.
0.716. Good.
Okay. And then I'm sorry to keep coming back to this, but I'm on 13. We have 0.193, or did we decide on 195?
195.
195. Okay.
Yeah, that was a typo, honestly.
Wait, what?
That was just a typo. My bad.
Gotcha.
So it is 195.
Correct.
Okay. All right. Thanks. All right. So I'll read 16, I guess. Find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7.
Oh.
There's a hint. Remember that to find this area between two values, shade to the left of each z-score you calculate, and then subtract the smaller area from the larger area. Make sure your answer is positive.
Yeah, because we already know the less than for both of those numbers. So all we do is take the greater one, so 0.716, and subtract 0.195 from that, and we get 0.521. You guys saw how I did that? I took this number.
Yeah.
So we took that, because it's the less than 0.7, and then we subtract it from the less than 0.6.
Yep.
And that should give us a number. Right?
Yep.
Oh, hold on. We're going to get Austin pulled up.
Okay, cool.
Okay. Zach, do you want to get 17?
Yeah. Find the 35th percentile for the protein requirement for adults.
So, 35th percentile, and my blue area is highlighted where it should be. And we're in the negative, so we use the negative z-score. Okay. Here on it. Oh, good. I calculated that.
All right.
Oh, 1.37. So the mean is 0.66. The standard is 0.07.
0.63 is the value that you didn't.
Oh,
Value.
oh, that's the value. 0.63.
It's a negative 0.385.
And let's just double check our work. Mean 0.66, and it is below the mean, so that should be correct.
So what did we have there? 0.65?
0.63.
Sorry.
Let me scan this out so more decimals though. That's what he wants, right?
Well, he doesn't say to round it.
Keep going the other one.
Yeah,
Third decimal place.
on all the ones that we did have to round, we put that. But maybe we don't have to.
It's 3 anyway.
Oh.
Just put the 3.
Okay. Okay. Well, I don't know. Do we want?
Oh, it's percent. So I guess we can just do
Well,
decimals.
no, it's a value. It's protein. Is what we're talking about. We're not talking about
Oh.
percent. Because the percent is 35.
Yeah, and all the protein values are in
3 decimals.
2 decimals.
2 decimals?
Uh,
Aren't they 2 decimals?
yeah, it is.
So keep it 2 decimals. And then 8.
Yep.
So we have 0.63, is that correct?
You got this. 0.842. So 0.842 is going to be divided by the 0.07 plus the mean. It's going to come out to be 0.719, so 0.72.
Okay.
Which is above the mean. And that is where it should be.
2. Okay, so we have 17 is 0.63 and 18 is 0.72, correct?
Yeah.
All right.
Ready?
Are we ready to submit?
Yeah.
Okay.
And 5. Yep. That's weird. 17 is wrong. How could it be wrong?
Oh, that's weird.
Let's see the minus thing. 3 to 9. Good.
Huh? Was that a rounding issue?
Here with okay. 0.385. Negative 0.385. Negative 0.3. Yeah, it still comes out the same. Maybe it's maybe she typed it in wrong.
Maybe, or maybe they, geez, maybe it was 3 decimal places. Well, but 18 wasn't, so.
Yeah, so that it's got to be right.
Yeah.
What the 5%?
Well, I'll submit mine if you guys keep them all.
I don't even know what the right answer is. Oh.
Yeah.
What question
Okay.
is that?
17.
17.
17.
Just all send emails and you'll play.
We're mad at you.
All right. Anything else, guys?
Do you want me to send my little Excel sheet to you guys at all? I don't know if you would be interested in that, but
That'd be great. Yeah.
kind of nice function. Let me look to see. I think I have everyone's email just from this thing. Let me look to make sure. If not, let me write them down on my Excel sheet. Okay, can I get, yeah, can you give me your email?
Yeah, it's IHUMES88 at Gmail.
Okay, and
Zach?
Yeah.
Zach, you want?
Yeah, so mine is FURIOUSTAPEWORM at
There's,
gmail.com.
there's got to be a good story to that.
Yeah,
Furious tapeworm.
and so it's like they're one of our emails, mini werewolf, the other one's flexing midget. It's like something small, like an adjective, and then like I don't know. So
All right. All right. Well, thanks, guys.
Yeah,
Have a
and
good
can you send the link to this on YouTube thing?
Yeah, I'll send it to you, Austin.
Okay, awesome.
All right. Thanks, you guys.
Yep.
Have a good weekend. Bye.
thanks, yeah.